Welcome to this, the second of 3 videos on recursion, and the first one on functional recursion, which is a really useful topic in programming. My name's Andy Wicks, and in this video we're going to look at how a calculator, or a programming language for that matter, finds square roots. You've probably never wondered how it finds a square root. Very few people do, but you're going to see it's not as difficult as it seems. First of all, I'm going to decide on the level of accuracy that I want. In this case, I want my accuracy to 4 decimal places, but obviously we could set that to whatever we wanted. It then asks me the number that I would like to find the square root of, and then it asks for a guess. That guess will become important, as you'll see in a moment. Having got those 2 pieces of information, it then prints out the square root of whatever the number is, and as you can see, it's looking for a function called Newton-Raphson, into which it's going to send whatever the number is I'm looking for and my original guess. That will return an answer, and that answer goes here. As a check, we're also going to use the system that the programming language, in this case Python, uses to find the square root. So we're going to do the same thing again. The square root of my number is, but this time we're going to use a bit of trickery. My number to the power of 1 divided by whichever root it is I'm looking for. So in this case I'm looking for the square root, so that's 2. So it's 1 divided by 2. If I was looking for the third root, the cube root, it'd be 1 divided by 3. If I was looking for the 27th root, it would be 1 divided by 27. But you can see that I've had to force these numbers to be used as floating point numbers. I need that decimal point in there to make sure that Python knows I don't want just whole number answers. So let's run this program. As you can see, it's asking me which number I would like to square root. I'm going to type in 2. And then it asks me what my guess is. I've got no idea what the square root of 2 is, so I'll assume that it's 1. And when I do that, it says square root of 2 is, and as you can see, these numbers are now the same right up until the final bit here. It's very accurate and very quick. So what we've found is the square root using a Newton-Raphson method, the method used by your calculator or programming language. But let's see how the magic happened. This is the Newton-Raphson function, and as you can see, it takes in these 2 numbers, the number that I'm looking to find the square root of and the guess. It then finds its next estimate of the square root, and it says, oh, that's equal to, and there's this function, 0.5 times the guess plus the number divided by the guess, and so on. You think, where has that come from? Well, it's mathematics. We don't need to know where that's come from. That's just a given. That's the trick of being able to use maths in programming. You don't have to know where everything comes from. You only have to be able to use it in your program. So here I'm saying that my next guess, xn plus 1, is equal to whatever comes out of this function. I then want to know whether the difference between my original guess and this new guess is less than the accuracy I've set. If it is less than the accuracy, then I can return my latest version of the guess. If it isn't, I then do the Newton-Raphson method again, giving it the number and this new guess. That's the clever bit. The guess that goes into the top is the new guess that it's calculated. That's the recursive step. And the base case is the absolute of the difference between the 2 guesses. Notice that in Python we need a return for each part. So obviously if we're returning from a function, we need to use the return statement. So return xn1 will give us the answer that we're looking for. But we also have to use the return for the recursion bit. You'll notice that the Newton-Raphson function is calling itself. That is recursion. That is functional recursion, because we're getting a function to call itself as many times as it needs to. And in this way, we can calculate the square root of any number we like without any difficulty whatsoever. Also included on the website is a program that allows you to see how to calculate the nth root of any number. But that's for those who are interested in the mathematics of these things. Thank you.